Today to the data case, we are from group 9. I'm Seow and my group member is Wong. So in this lab session 1, we are going to design wing bridge oscillator with different frequencies. In this design 1, the value of resistor R1 and R2 used is 14.469 kilo ohm and the capacitor volume is 22 nanofarad. And let's check at the output waveform. The output waveform is not perfect sine wave but has some distortions. The period of the signal is 2.008 milliseconds as shown here, and when we use this value and substitute into the formula f equals to 1 over t, we will get a frequency about 498, which is very near to our targeted frequencies of 500 Hz. Well, for the next circuit, the targeted frequency will be 1 kHz, and this is the circuit R1. The value of R1 and R2 is changed to 7.234 kilo ohm, and C1 and C2 is still the same value. And let's check at the plot. So the plot is still have some distortion, it's not a perfect sine wave. And the period of this circuit is about 1.004 milliseconds, and it gives frequencies of 996 Hz, which is very near to our targeted frequency. This is the same circuit, but it already has the amplitude stabilization effect. We have added 2 diodes, and the potentiometer was used. And now you can see the wave is more smooth and a perfect sine wave with no distortions. The period of it is about 1.004 milliseconds, which gives the same frequency, 996. For the third circuit, the targeted frequency is 2 kHz, and the value of resistor R1 and R2 used is 3.617 kilo ohm, and C1 and C2 is still the same, 22 nanofarad. So let's check at the output waveform. The output waveform is distorted and is not a perfect sine wave. The period of this circuit is about 549.242 milliseconds, and when we use it to calculate frequency, we get 1820, which is very near to 2 kHz. This is the same circuit with stabilizations. 2 diodes was used and a potentiometer is used. So let's check at the output plot. And we can see that the output wave is very smooth without any distortion. The period of this circuit is 511.364 milliseconds, which gives us the frequencies of 1955, very near to 2 kHz.
In this circuit, we are supposed to achieve the frequency which is 3 kHz. As we can see, the resistor we use is 2.412 kilo ohm, and the capacitance value is 22 nanofarad, which is same for each circuit. So now, let us run the circuit. The waveform is not smooth and seems to have distortion. So the period of the waveform is 361.29 millisecond, and the frequency we get is 2.8 kilohertz. So this is another circuit. The different part of this circuit with the circuit just now is we have added amplitude stabilization effect. As we can see, we have added two diodes and the potentiometer are used. Let's check the waveform. So we can see this waveform is more smooth and shows a more perfect sine wave compared to the circuit just now. The period is 345.161 millisecond and the frequency we get is 2.9 kilo ohm, which is nearer to 3 kilohertz. We are supposed to achieve the frequency 5 kHz. As we can see, the resistor we use is 1.447 kilo ohm and the capacitance value is 22 nanofarad. So let's run the circuit. We can see that the waveform is not so smooth and have distortion. The period of the waveform is 238.71 millisecond and the frequency is 4.2 kHz. The different part of this circuit with the circuit just now is the amplitude stabilization effect. In this circuit, we have added two diodes and potentiometer are used. Now let us run the circuit. We can see clearly that this waveform is smoother and have a more beautiful sine wave compared to the circuit just now. The period is 206.452 millisecond and the period is 4.8 kHz, which is nearer to 5 kHz.